So in this lab today, we're going to look at the difference between mass and volume. Okay, we're going to look at the difference between mass and volume for one of these pieces of aluminum here, right, these little cylinders of aluminum. We're going to look at the mass and volume of water, so liquid water. And then the third part of this lab, we'll be looking at a carbon dioxide in a gas form. Okay, so we're going to be looking at a solid here with aluminum, a liquid with water, and then we're going to create a gas of carbon dioxide later. And we're going to look at the difference between the mass and the volume of each of those. Okay. So the first thing we're going to look at is the piece of aluminum. Okay. So a place for a data table there on your lab handout. So you're going to just fill these in as we go along. Okay. So to get the mass, right? The other day we learned that we're going to use the balance here. Okay, to get the mass. Right. We learned that in our other lab on the first day of the semester. We use that to get the mass. So we're going to do the same thing here. So for this first piece of aluminum, the mass is 10.8 grams. Okay, so 10.8 grams you're going to record in your data table at 10.8 grams. And so then we need to figure out what the volume of that is. Now, volume, maybe learn from math. Maybe we could do like length times width times height on this piece, or the cylinder we could do. Let's see, we could figure out the area of the end. What is that? 4/3 times pi radius squared, and then times the height. But we don't need to do that. Okay. In science, we could use this graduated cylinders instead, and use the water displacement method. So the water displacement method is, I'm just going to fill up this graduated cylinder, to enough water that when I drop this in there, it's going to cover that. It's going to cover that up. So I'm going to see, let's see, I'm going to try and fill this. I kind of just random filled it, but it's at 60 right now. Okay, so it started, I'm just going to write that down. Started at 60 ml, 60 milliliters. Okay, and then when I drop this cylinder in the graduated cylinder, it's going to make that water level go up. Right, it's there on the bottom. I made that water level go up. So if it was 60, it went up to looks like 64.2 milliliters. Right, and it was right at 60. Okay, so I would do a subtraction, and then that would leave me at 4.2, right, milliliters, okay, for the volume on this guy. Okay, so 10.8 grams, 4.2 milliliters is what we'd have for our first piece of aluminum. Okay. Now, we're going to go ahead and do that same process here for this second piece of aluminum. So this water can dump back out. Okay, right, I have this piece right here. I'm going to go back in my thing here, and I'm going to do a little bit bigger piece. Okay, so this piece is a little bit bigger than the piece we started with a second ago. Just going to dry this off a little bit, and I'm going to record the mass again. So the mass of this is aluminum piece 2. We're going to get 18.7 grams. Okay, 18.7 for the mass. 18.7 grams. Right, and again, grams is just the unit of the metric unit of measurement for mass. All right, this time I got that set at 51. All right, so I'll let you guys do the subtraction this time. but it's right at 51.0 milliliters. Okay. Right, and then what do you guys think is going to happen to this second piece compared to the first? Right, when you looked at what happened to the mass, did it go up or did it go down? What about the size of the piece? Just from looking at it, what should happen here to the volume when I drop that guy in? Okay, let's see what we get. In the end, it's looks like 58.0. So it was 51.0. Right, you guys can do that subtraction, right? 58.0 minus 51 gives you however many milliliters that second piece of aluminum, you know, how many milliliters that one is, how much space that takes up. Right, it takes up, because it takes up 7 milliliters of space in the water there. Okay, so again, we're going to move on to the next one. 2 more of these pieces left. So next piece is even a little bit bigger than that last one. And we get 27.0 grams. 27.0. Mass is 27.0. Again, same thing. I'm going to fill this up just to some line, you know, that where I can get it on to like a even 0 would be good. Nothing specific. Okay, perfect. 46.0. Let me check that again. No, that's 47. 47.0. Okay. We'll see how much space that guy takes up. I made a little bubble when it dropped in that time. And it looks like it is at 57.2. That is our final value. Okay. So, right, you guys can look at those again. 28.0, 57.2 is where it ended. The water level started at 47.0. Right, you guys can subtract those and fill in your data table. Okay. And then one more piece after that. This is even, right, this piece is like almost a finger length, even bigger piece. Let's try that off. Right, you should be able to kind of, maybe you should probably even guess about what this is going to be from there. It is 38.4 grams. 38.4. Okay. And then we'll get the volume of that. All right, that is at 49 exactly, or 49.0. Drop that in slowly if I can. Okay, right, and it's in there. You can see it raised the water level up to 63.0. Right, again, you guys can do that subtraction and then fill that in for the volume on your data table. Okay, and then we have, those are our 4 pieces of evidence, pieces of data for the mass and volume of the piece of magnesium, or the piece of aluminum. Okay, so now we're ready to record our mass and our volume data for water. Okay, and this is going to be a little bit different. Procedure is going to be a little bit different. We're still going to use a graduated cylinder, and I just grabbed a smaller one here. Right, we can record water in this the volume of this pretty easily, right? If I just pour some water in there and then record the volume, okay, we won't have to do any subtraction or anything. So we're just going to take 4 measurements again. I'm just going to pour 4 random amounts of water in there and read what the volume says. Okay, because it really doesn't matter how much we're talking about. But I'm just going to use a small amount so it's easier for make your graph here in a second. So the volume part is pretty easy for the water. Now the mass part, right? When we had the cylinders, right? All I had to do is take the cylinder and put it on here, right? And it gave me the mass. Now water is a liquid, so that's going to be a little bit trickier to do, right? We can't just pour a liquid onto that balance. But what we can do is the water while it's in the graduated cylinder, we can put that onto the balance and record the mass of that, right? Now that would be the mass, right? That mass that we would record is the mass of the water plus the graduated cylinder. So 2 things we could do. We could put this empty graduated cylinder first on here. And that weighs 11.2 grams. And we could subtract off 11.2 grams every time, right? And then we'd get the mass of the water. But the scale has this nice feature where I can just press the 0 button. Now my scale reads 0.0. So it's like subtracting off the weight of the mass of the graduated cylinder every time. So when I put this back on here now, as long as I don't hit the 0 button again, it's going to be just the mass of the water. Okay, so we'll go ahead and start with just a small amount of water here. Okay. Not spill it, hopefully. And then if you remember the graduated cylinders, you got to read to the bottom of the meniscus, the bottom of the little curved line there. So this one is at 4.4 milliliters. Okay, so I'm going to write the volume first because that's easier to record for the water. So this first amount of water, right, is 4.4 milliliters. And then we will see how much what the mass of that is. So 4.4 milliliters has a mass of 4.3 grams. Okay, so this is for the water now, right? You have a mass of 4.3 grams, a volume of 4.4 milliliters. Okay, so that's our first data point. Okay. Now with the water, look, I could pour this out and then start over, but I could just add a little bit, right? Because water is not gonna, it's the same, I'm adding the same material. So I'll add a little bit of water to that. It is now the volume is at 7.0 milliliters. Okay, so the volume is at 7.0 milliliters. Let's see how much that weighs. Well, that's also going to be 7.0 grams. Interesting. So 7.7 milliliters, or 7.0 milliliters was the volume. 7.0 grams is the mass for that second amount of water we had there. Okay, so that's 2 sets. I'm going to add a little bit more water to that. All right, and now it's at 9.2 for the volume, 9.2 milliliters. And that's going to give me 9.1 grams. And 9.2 milliliters, 9.1 grams. All right, that's our third set, and then we need to do one more. Okay, and a little bit more. See what happens from there. That is 11.8. 11.8 milliliters. Okay, can we predict maybe about what the mass would be? Have a guess? Let's see. It's actually it's at 11.9. It's reading. Okay, so 11.8 milliliters for the volume, 11.9 grams for the mass. Okay. Now your next step here on this lab is to take the data that you just recorded and make a graph on the graph paper that's provided. You're gonna plot the points for the aluminum in one set, and you're gonna make a best fit line. You should get a straight line, and then find the slope of that. Now on the same graph, you're gonna plot the points of the water data, the volume on the y-axis, or on the x-axis, the mass on the y-axis. You're gonna find a best fit line of that, and you're gonna find the slope of that. Okay. So also you have to go about making a scale for your data there, and then make your graphs and calculate your slope.